how would we convert a base 10 number to binary? Now we looked at 3 in the last slide, but we haven't yet. Up until now, we've only taken binary numbers and converted them to base 10. To convert from base 10 to binary, here's what you do. You don't know, at first glance, you don't know how many place values you're going to need. But you start to construct the place values. The 2 to the 0 place, which is the 1's place. The 2 to the first power, the 2's place. The 2 to the second power, the 4's place. As soon as I get to the 4's place, and I realize I'm trying to represent 3, I realize I've gone too far, because I don't want any 4's. By the way, how many 4's could I have in binary? I could only have 0 4's or 1 4. Well, I want 0 4's, but I don't need to start my number with a 0. Just like if you were representing 3 in base 10, you wouldn't write 0 3. You would just write 3. And so I don't need any 4's, but I do need a 2. I need a 2, and then I have 1 left over to represent 3, so I need a 1. I need a 2 and a 1. I need 1 2, which is 2 in base 10, and I need 1 1, which is 1 in base 10. So if I have a 1 and a 1 in binary, I have 2 and 1 in base 10, I have a 3 in base 10. So the way you represent the binary numbers, the way you take a base 10 number and convert it to a binary number, is by first considering the binary place values, and then it's sort of like going shopping, and that'll make more sense with a bigger number, but I'll show you. You go shopping for place values. Do you want a 4? Do you want a 2? Do you want a 1? And you take what you need to construct that base 10 value.